All right, let's go ahead and get started on today's notes. So before we can continue on in our Algebra 1 journey, we actually need to spend some time reviewing factoring. So we're going to review factoring today. Now, I uploaded on Schoology a copy of our factoring cheat sheet. So if you didn't have a chance to take all your math stuff home and you weren't able to get your cheat sheet to your house, there's a copy online for you, and you can just copy it down onto a piece of notebook paper or whatever you need to do. So the first thing we're going to do is we're going to review factoring when a is equal to 1. So if you recall, when we talk about degree 2 polynomials, we talk about it in the form of ax squared plus bx plus c. So the first thing we need to talk about is factoring when a is 1. So for example, if a is 1, over here in example 1 part A, we have x squared plus 5x minus 6. So a is 1, because there's technically a 1 here in front of x squared. B would then be 5, and c is negative 6. So we're focusing on factoring when a equals 1. So step 1 when you factor, in this case, is you want to make a factor tree for c. So in our case, c is equal to negative 6. So we need to make a factor tree for negative 6. However, when I make a factor tree, I don't really need to worry about whether or not c is positive or negative. So I'm just going to make a factor tree for positive 6. So when I make this factor tree, the very first factor of 6 is 1. 1 times 6 is 6. Then 2 and 3. So I have 1 times 6 is 6. 2 times 3 is 6. So we need to pick factors of 6 that are going to add or subtract to give us b, which is 5. So that's step 2. Pick factors of c that add or subtract to get b. So in this case, 1 and 6 and 2 and 3 will get us positive 5. However, I know that when I multiply, I need to end up with a negative 6. And so to get a negative 6, I can only have one of these be positive and one of them be negative. So I'm going to stick with 1 and 6. Because I can have one of them be positive, the other be negative, and they'll add to get me 5. So then step 3, once we've picked up those factors of 6, once we've picked them out, we are ready to set up our factors. So that's step 3. Step 3 is to set up the factors. And last but not least, multiply to check. So we have x squared plus 5x minus 6. I'm going to go ahead and set up my two factors. I know that something times something needs to be x squared. Well, x times x is x squared. Then something times something needs to give me 6, so I'm going to use 1 and 6 like we picked out earlier. And then I need to put signs in between x and 1 and x and 6. Well, I know when I multiply I need a negative, so either the 1 or the 6 needs to be negative. And when I add or subtract, I need a positive 5. So I'm going to try out negative 1 and positive 6. Now, how can I absolutely positively make sure that this is correct? I can multiply to check. So I have x minus 1 times x plus 6. X times x is x squared. X times 6 is 6x. Negative 1 times x is negative x. And negative 1 times 6 is negative 6. When I combine my like terms, 6x and negative x, I get x squared plus 5x minus 6. And there we have it. This x squared plus 5x minus 6 is what I started out with originally. So I know that x minus 1 times x plus 6 is in fact the factored form of x squared plus 5x minus 6. Let's repeat this process for part B. So for part B, we have v squared plus 3v minus 28. Sorry, I got ahead of myself there. So my very first step is to make a factor tree for C. This time C is 28. I'm going to make a factor tree for 28. And I don't know if you can hear it, but the ice cream truck has been driving up and down my street every single day since we've been in quarantine. And the music is really loud. And of course, my puppy feels like he needs to chime in and bark at the ice cream truck, remind it to go away. All right, I think we're all good now. So I'm going to make a factor tree for 28. The first factors of 28 are 1 and 28, 2 and 14, 3 doesn't go into 28, 4 and 7. And I think that's it. So now we have, we need to pick factors of C that add or subtract to get us B in step 2. So to get 3, I could use 4 and 7. So now I'm going to go ahead and set up my factors. I know v times v is v squared. 4 times 7 is 28. And then I need a positive 3 when I add or subtract, a negative 28 when I multiply. So because c is negative, that tells me that one of these factors needs a negative sign. And I need a positive 3 when I add or subtract. Because I need a positive 3 when I add or subtract, I know that the larger number 7 needs to be positive. The smaller number can be negative. So let's make sure that this is correct before we turn it in as our final answer. V times v is v squared. V times 7 is 7v. Negative 4 times v is negative 4v. Negative 4 times 7 is negative 28. Combine your like terms. 7v minus 4v is 3v minus 28. And that checks out. Matches what we started with. So that tells me that this is, in fact, the factored form of v squared plus 3v minus 28. Go ahead and try example C on your own. A squared minus 7a minus 18. All right. So what times what is a squared? A times a. Factors of 18 that add or subtract to give us 7. Two and 9. We need a negative 7 when we add and a negative 18 when we multiply. So your factors should be a plus 2 times a minus 7. All right, let's move on to example 2. So example 2, we need to factor when a is equal to negative 1. So this time, instead of having a be a positive 1, out in front here we have a negative. So in this case, a is negative 1, b is negative 19, and c is negative 16. So the very first thing we need to do is we need to make a become positive 1. To do that, let's factor out a negative 1 from every single term. So if I factor out a negative from negative w squared, I'm left with w squared. If I factor out a negative from negative 19w, I'm left with positive 19w. If I factor out a negative from negative 60, I'm left with a positive 60. Now we have a equals 1, b equals 19, c equals 60. So we're ready to follow our normal steps of factoring. When you set up your factors, you want to make sure that negative 1 is still out in front, because this negative 1 is one of our factors of this original problem. So this problem is actually going to have 3 factors. Negative 1, whatever is in these parentheses, and whatever is in these parentheses. So let's do this. Let's take C, which is 60, and let's find all the factors of C. If 5 and 12, I think 6 and 10. All right, so now we need factors of 60 that add or subtract to give us this positive 19. Well, 4 and 15 will work for that. So I'm going to have a w times w to get w squared. I'm going to have a 4 and a 15. And I need a positive when I multiply and a positive when I add, which tells me that both factors have positives in them. So let's double check this just to make sure that we're right before we circle it as our final answer. So I'm going to leave this negative out in front for now, and I'm going to multiply w plus 4 and w plus 15. So w times w is w squared. W times 15 is 15w. 4 times w, 4w. 4 times 15, I don't have enough room, is 60. All right. I'm going to combine my like terms, and I'm going to get w squared plus 14w plus 60. I'm going to distribute that negative, and I'm going to distribute the negative to w squared, 14w, and 60. So negative w squared, negative 14w, and negative 60. And it checks out. So I know that this is in fact my final answer. Negative 1 times w plus 4 times w plus 15 is in fact the factored form of the original problem. I'm going to give you a second to go ahead and work through B. So for B, you should have factored out that negative first thing. Then make a factor tree for 24. Find factors of 24 that add or subtract to give you that negative 11. And I need a negative when I add, a positive when I multiply. So that tells me that this 3 needs to be negative, and so does the 8. Because a negative 3 times a negative 8 will be positive 24, and a negative 3 plus a negative 8 is a negative 11. So this should work, and when you check it on your own, you should find that it works out perfectly. So real quick, I would also like to try factoring a difference of squares. Let's go ahead and review this. So when we factor a difference of squares, difference means to subtract. If you see a difference, that means there has to be subtraction. And squares just means perfect squares. So for example, 9 is a perfect square because 3 times 3 is 9. Let's see, 49 is also a perfect square because 7 times 7 is 49. So whenever you have a difference of squares, for example, a squared minus b squared, we have subtraction, and a squared is a perfect square because a times itself is a squared. B squared is also a perfect square because b times itself is b squared. So when I factor a squared minus b squared, my factored form is always going to be a minus b times a plus b. And if you notice, the square root of a squared is a, the square root of b squared is b. So I just put a and a, b and b, subtract and add for your signs. So let's apply that rule to some examples. X squared minus 49. X times x is x squared, and 7 times 7 is 49, and then I just need a positive and a negative in the middle. And real quick, we're going to go ahead and check this example just to make sure we're right. X times x is x squared, x times negative 7, 7 times x, and 7 times negative 7. When I combine like terms, I notice that negative 7x and positive 7x cancel each other out. So I'm left with x squared minus 49, which matches the original problem. So I know x plus 7 times x minus 7 is the factored form of x squared minus 49. Why don't you go ahead and try example B and C real quick? You can pause the video, and when you're done, press play and check your answers. So x squared minus 100, the square root of x squared is x, the square root of 100 is 10, and then I know I need a positive and a negative sign. 4x squared minus 81, this one's just a little bit tricky because instead of just x squared, we have 4x squared. Well, isn't the square root of 4 2, and the square root of x squared x? So that means that the square root of 4x squared is 2x. So I have 2x and 2x. The square root of 81 is 9. And then I'm going to have a positive and a negative. So the same rules apply, even though this problem looked a little funky to begin with. And if you check these on your own, you'll find that we have the correct answers.